We are discussing the Organic Chemical Technology course module 8, and that is about the polymer, elastomer and synthetic fiber. That is we are having 8 lecture in this. Already I discussed in the lecture 1 about the general introduction to the polymer, elastomer and synthetic fiber. What are the various types of the polymer, elastomer, synthetic fiber, and what are the driving force for the development of these 3 important class of the polymer, that is the plastic, elastomer and the synthetic fiber. And in that also we discussed the various type of the reaction that is taking place in the manufacture of all the polymers, whether the elastomer or synthetic fiber or the plastic or the polymer as such. So the and the different type of the reaction, different type of the process that we are, because those processes are also being used in the various whether you are manufacturing the polyolefins or other polymers. And so this lecture that will be about the polyolefins, polyethylene and polypropylene and polystyrene, because these are the 3 important polymers, especially the ethylene and the propylene that has come in the large number, the large increase in the capacity that has been with the coming of the petrochemicals, the cracker plant, naphtha cracker and the gas cracker, and with the availability of the ethylene and the propylene. And similarly in case of the polystyrene, with the availability of the benzene for making the ethyl benzene and ethyl benzene to styrene. So this will be the coverage of the lecture introduction, general about the polyolefins, and then we will be discussing of the polyethylene and polypropylene, catalyst and development for the various type of the catalysts we are using in case of the polyolefins. So Metallocene catalyst that has been actually the change in the whole pattern of the making of the polymers. And in polypropylene, what are the various type of the polypropylene that we are making, that will be discussed. Process technology for manufacture of these 2 in detail we will be discussing, and then the polystyrene. So this will be the broad coverage of the lecture. So polyolefins are high polymers produced by polymerization of the olefin. Polyethylene, the various, as I told you, the various grade of the polyethylenes are there: LDPE, low density, high density, linear low density polyethylene, and the polypropylene. Also in the polypropylene, different grade of the polypropylenes are there. So these are the main polyolefins that we are producing. Polyolefins such as polyethylene and the polypropylene are commodity plastic and found in application in vary from household items such as grocery bags, containers, carpets, toys, appliances, to high technical products such as engineering plastic, industrial pipes, automotive parts, medical appliances. Just like in case of the polypropylene, it is finding large application in the medical appliances and even the prosthetic implant. Because now we are talking about the artificial part of the body. So from where, so we are using different type of the polymers there. Even in case of the large variety of composites are also available. So ethylene and propylene are the monomers for the polyethylene and the polypropylene, because you see that these are the 2, as I told you, the starting also the ethylene and the propylene, their availability from the petrochemical complexes, that has played important role in the development of these 2 major products. In India, the domestic polymer industry is dominated by polyolefins, means the polyethylene and the polypropylene. And you see in India, so far the polyolefins are concerned, Reliance, Haldia and the GAIL, these are the major. And now the IOC that is also coming, and the ONGC, after coming of the ONGC, they will be also a major player in case of the, but at this stage the Reliance, then Haldia and the GAIL. These are the three, but still the major share is of the Reliance. So for the polyethylene, the polypropylene is concerned. Polyethylene is the one of the most widely used thermoplastic, and its ever increasing demand is due to availability of monomer ethylene, which I told you from the naphtha and the gas cracker. First polyethylene plant was based on the ethylene from molasses. That was the actually Risra. They started a small polyethylene plant with the based on the ethylene from the molasses, and then it was the after coming of the gas small cracker plant, naphtha cracker plant by Union Carbide in Bombay. So that was the smaller plant capacity that was, but after that, after coming of the NOSL, IPCL, now Reliance Industry, and then the Reliance Hajra project, GAIL, so lot of the production path changes in the production that has come in case of the polyethylene as well as the polypropylene. Some of the driving forces, other driving forces is the fast growth of the use of polyethylene or ease of the processing the polymer, its relative cost, resistance to chemical, and its flexibility. These are the some of the major driving force for the adaptability of the polyethylene. So as I told you, we are making the different grade of the polyethylene. So low density polyethylene branch produced by high pressure. So LDPE, medium density depending upon the density, this also 0.940. So 0.920, 0.940, 0.94. So depending upon the density you can differentiate whether it is the, and even the crystallinity that is also changing. LDPE melting point, slight difference in the melting point is also there, and the linear high density to ultra high density homopolymer that we are also making in case of. So these are the broad grade of the polyethylene that we are making. This is the some of the your application you are finding in case of the polyethylene packaging industry. Also we are having the packaging many of the conventional glass that has been replaced with the, it may be the polyethylene, it may be the PET in case of the mineral water. So all those things that is the for the containers for packaging edible oil, processed food, lubricants, detergent, chemical, pesticide, industrial crates, and the containers, carrier bags, housewares, ropes and fins, pipes of water supply. Everywhere they are using in some other form, either, although the PVC is more. These are the some of the so far the piping is concerned. I was telling about the PVC, more PVC pipes in irrigation and the household, and they are there. So these are the some of the major catalyst development in case of the polyolefin. Ziegler Natta catalyst, from chrome Metallocene, that has come in a big way in case of the manufacture of the polypropylene. Polyolefins by Metallocene catalysts have created revolution in the polyolefin production on account of their unprecedented potential in tailoring the molecular structure. It has resulted in various new applications of the polyolefin. This is the actually the now the process is using this catalyst for polypropylene. They have a lot of the changes in the quality of the product is there. In Metallocene catalyst, each catalyst molecule has same activity and accessibility to the monomer, which was not there in other type of the catalyst. So that is very important. Metallocene catalyst has inherent ability to produce extremely uniform homopolymer and copolymer of a very narrow molecular weight distribution, high temperature stability. Very narrow molecular weight distribution means more uniformity is there. So this is the advantage why the Metallocene catalyst they have enter in the manufacturing of the, and the why the wide applicability of the Metallocene catalyst is there. This is the just comparison why the what are the advantage, important characteristic, activity and yields. Very high activity towards mono, co and the turf polymerization with very high turnover time, Then they produce very high molecular weight, very sensitive to the hydrogen, and only trace amount is required to control molecular weight, highly stereoscopic in nature. Comonomer is highly random and the homogeneous. Can incorporate polar monomers, provide polymers which are highly linear. Polymer exhibit low heat temperature, and then the polymer with low H, low high, the action extractable mechanical property. Tailoring of the products can produce tailor-made product. So these are the some of the characteristics of the metals in catalysts and the copolymers, and why we are using more now the metal catalyst based process are there. Now let us discuss about the polyethylene. As I discussed, these are the some of the the broad classification. Already we discussed about the low density, high density, and the accordingly the process technology that has been also developed. This is the molecular mass advantage, low cost, extend dielectric properties, moisture resistance, very good chemical resistance, ability in the food grade process by all thermoplastic method. Several process has been commercialized for the manufacture of polyethylene with a varying density. This is how the branch and the linear polyethylene look like. Polyethylene process, actually as I told you, there are various process licenses and different type of the process that has been developed for producing wide variety of the polyethylene. That is one of the parts is the saline gas phase process, very low density polyethylene. So that is LLDPE, VLDPE, they also call this process VLDP, LLDP, high density polyethylene, and then the Ziegler Natta titanium based catalyst that we are using, and Basel is the your process licensor. Broster P, biomodel and unimodel LDP, Ziegler Natta catalyst and licensor the Broils. Yes. Innovin gas phase, that is Ziegler Natta caustic catalyst that we are using. Chromium or the metals catalyst that can be licensor BP. High pressure ICI process for LDP, Ziegler Low process for HDP, Phillips process linear polyethylene licensor Chevron Phillips, ExxonMobil LDP homopolymer and the ethyl acetate copolymer. Other process licensors, CX process for SDP, MDP, low slurry process licensor is Mitsubishi Chemicals, UNIPOL process, LLDP, SDP, fluidized bed reactor we are using in this process. Then the Hostelim process, SDP using stirred tank, high activity Ziegler catalyst we are using here, licensor Basel Polyolefins. Then the LLDPE TS are the TM modular reactor process. This is the LDP homopolymer EVA copolymer, licensor is the your Basel polyolefin. So these are the some of the commercial process that is available for making of the different grade of the polyethylene. This is the again in process polymerization in fluidized reactor using Ziegler Natta. This is the temperature condition, and this is the product that we are getting. Broster process uses slightly more detail about that process, that was not there, only I gave the various process. So here in case of the Broster process uses gas phase low pressure reactor, Ziegler Natta case Comonomer hydrogen, pre-polymerization in the slurry loop reactor and a fluidized bed reactor, temperature 75 to 100 degrees centigrade, bimodal and unimodal LLDP and the medium density polyethylene. High pressure free radical process by Exxon Chemicals. Polymerization occurs in the autoclave reactors or the tubular reactor, and the LLDP linear low density polyethylene that we are making by this process. Spheripol gas phase process Montel technology that we are having the polymerization in gas phase reactor using the Ziegler Natta catalyst. Here the linear low density polyethylene or the high density polyethylene, that is the product we are getting. Phillips low polyethylene, low density polyethylene process, polymerization takes not low, linear polyethylene process. The polymerization takes place in an isobutene slurry using very high activity proprietary catalyst in loop reactor. So this is the linear polyethylene. So UNIPOL process, and the process produces low density polyethylene and high density polyethylene using low pressure in the gas phase, and this is the fluidized bed reactor. In the fluidized bed reactor, after the polymerization is completed, then it will go to the cyclone, the separation of the catalyst that will take, and the polyethylene that will be getting from here, and then it is with the recycled unreacted part that will be the gases that will be recycled here. Here it will be separation of the polyethylene that will be there. And DuPont SCLAIRTECH process a broad range of the polyethylene with a density varying from 0.919 to 0.965, varying melt indexing can be produced. Various melt index, that is the actually this is the one of the new process, the modified process where the high varying melt index can be made by this process. The process can be divided into three major areas: reaction area, recycle, recovery area, extraction and finishing, and downturn vaporizer. These are the some of the units, various steps are there. This is the by SCLAIRTECH process, that is the butene. Here we are using the copolymer, cyclohexane and the solvent, and ethylene monomer that is going to the polymerization reactor, and then the ethylene butene cyclohexane again, that is the recycle, and then the finishing after the catalyst, and here the co-catalyst, deactivator, additives, and the polymer pellets that you are getting in this process. Now let us this was the various processes that is available for making of the polyethylene. Now we will be discussing about the polypropylene. Polypropylene is a low density semi-crystalline stereoregular polymer which exists in three forms: isotactic, cyanodiotactic, and the atactic. So these are the three forms of the polypropylene. That prior to 1954 only cationic or the free radical catalysts were known to promote the polymerization of the propylene. This is the actually, if you see the this is the courtesy of the Reliance industry. This is the because they are the major manufacturer of the polypropylene, and so the you see the, as I told you, in case of the hospital where the conventional the syringes and the bottles, glass was being, that has completely replaced the had been replaced by polypropylene syringes. That is the 1.5 billion huge. Now we are with the coming of the polypropylene at a very cheaper rate. Now it is the disposable syringes, millions of masks that we are using, caps usage in the hospitals. These are all actually the polypropylene fibers also that is being used. Growth drivers are the rise in the senior citizen population, health awareness, and hence more disposable. India and the medical tourism destination, propylene uses 30 kilotons per annum. So good growth in the healthcare industry, and these are the some of the, this is the syringe and the bottles, glucose bottle. Earlier that used to be the glass. So you see the even the this the mask and other thing, that is also we are using the. Similarly, you see the other application of the rigid packing. This is also one of the, here the growth driver for the polypropylene are the increased consumption and growth in the organized retail food processing, horticulture, dairy sector, increasing health, safety concern, disposable single serve packing format. So polypropylene, that is 250 kilotons. New applications are also there. Glass replacement, multi-wall containers are the growth drivers. So these are the some of the containers made of the polypropylene. Phosphoric acid, because that was the earlier in the catalyst, what was the problem? The phosphoric acid gave highly products, later BF3 alumina silica H2SO4 hydrofluoric acid aluminum halides were used as catalysts in polymerizing the propylene, but the Ziegler Natta catalyst, that was the mostly widely used catalyst. There are three structures in the polypropylene. The ratio of the various structure depends upon the catalyst and the operating condition used. So already I told you the isotactic or stereo or the regular, and the different type of the actually the configurations are there. The atactic, there is another the second and the third is the cyanodio-atactic. Ethylene propylene copolymers are also there. Using Ziegler Natta catalyst, ethylene and propylene can be copolymerized to yield the elastomer. Technology used by various producers are different but involve the following step: polymerization of propylene by continuous process, copolymerization of ethylene and the propylene with the first polymer using the same catalyst in the second step. So this is the polypropylene process that we are using the propylene, that is going to the polymerization, then the raging, decasing, pelletizing, and then the products. So this is the simplest actually the one of the process where you are using the that you can make how we are making the polypropylene pellets. This is the UNIPOL process where we are using the your fluidized bed reactor propylene, that is going to the polymerization reactor, and then the here we are having the reactor 1 and reactor 2 and the fencing reactors, and then finally the polypropylene resin that we are getting in the final stage. So this is the process, UNIPOL process, where we are using the fluidized bed reactor. This was I was telling about the why the three structures, they are very important in case of the polypropylene, that is the isotactic, stereo, regular, boiling and heptane, insoluble, highly crystalline, high temperature. The atactic, stereo, irregularity, generally soluble in boiling and heptane, low melting temperature. Here in case of the cyanodio-tactic, that is stereo regularity different than the isotactic, very low degree of crystallinity, not much in the practical area. These are the summary of the processes in case of the polypropylene that is available. That the Broster Polypropylene Process, license Brawless, and the produced by bulk polymerization loop reactor, followed by the final gas phase reactor. So two-stage process. That is the Spheripol process, Montel technology, homopolymer and random copolymer polymerization takes place in liquid propylene in a loop reactor. Heterophasic impact copolymerization is done by adding a gas in the gas phase reactor. Then the Nolan process, that the polymerization is conducted in one or two gas phase reactors connected in series. Union carbide gas, that gas phase UNIPOL process, a wide range of polypropylene is made in gas phase fluidized bed reactor using proprietary catalyst. Then the Spheripol process technology, that is new proprietary gaseous technology based on the multi-zone circulating system that is there. This process, Spheripol process, this process can produce a broad range of propylene polymers including the homopolymer, polypropylene, random copolymer, pteropolymer. Terpolymer means the two this monomer, additional monomer that may be there, heterophasic impact, specialty impact as well as high stiffness copolymer. In this process homopolymer and the copolymer polymerization takes place in liquid propylene with loop reactor. Heteroscopic impact copolymerization is achieved by adding a gas phase reactor. This is the process which you are having the two stage reactor here, the finishing this is called the impact reactor, and finally will be getting the your polypropylene there in the process. Now let us, this was about the polypropylene manufacture, and as I showed you the polypropylene, that was the actually the automobile sector that has come in a big way, and the a huge amount of the polypropylene that we are using in the automobile sector, where we are making the bumper and other materials of the polypropylene. That is after, certainly after the processing, that polypropylene that we are using. So another important this polystyrene is a important thermoplastic. When styrene is copolymerized, different type of the combination of the styrene with the acrylonitrile and butadiene is there. So when the styrene is copolymerized with the acrylonitrile, the polymer is styrene acrylonitrile sand. Resin has a higher tensile strength than the polystyrene. Next is the acrylonitrile, because in case of the combination of the polystyrene, the acrylonitrile butadiene styrene polymer has special mechanical properties and fine application as the engineering plastic. Styrene, as I discussed in the while discussing the petrochemicals, we discussed the manufacture of styrene. That was from the ethyl benzene, dehydrogenation of the ethyl benzene, which is made by the alkylation of the benzene. So the benzene and the ethylene, that was the two major raw material for the styrene. And so with the development of the petrochemical industry, now we have been able to make the polystyrene at the cheaper rate, and the polystyrene that is find wide application in the industry. So styrene copolymerized with the adiponitrile resulting in the acrylonitrile resulting the sand polymer is characterized with the high tensile strength than the polystyrene. So this is the reason, because the specialized plastic we are using this styrene acrylonitrile plastic that we are using. Another important styrene copolymer, that which I told you, that the acrylonitrile butadiene ABS plastic, which is used in the engineering plastic and is characterized with the special mechanical property. Even we are having the polymer metal composites also. So ABS, they are also being used in case of the some of the composite in the automobile sector also. So that is the importance in case of the when we are acrylonitrile and butadiene are also there when we are polymerizing the styrene, acrylonitrile and butadiene. We are discussing the various polystyrene process technology, and one of the process is Nova's polystyrene technology. The process produces a complete range of general purpose crysts and the impact resistance polystyrene. This is based on the bulk continuous polymerization technique. This is the polystyrene process technology by UOP. This process is based on continuous bulk polymerization to produce a wide range of general purpose polystyrene, because we are having the different grade of the, one is the general purpose polystyrene and the high impact polystyrene and the expandable also, but here we are making these two type of the general purpose and the high impact polystyrene and styrene resin. A typical plant includes feed preparation, a reactor section, devolatilization section, monomer recovery section, water removal, product pelletizing and the bulk resin handling. Another quality of the this polystyrene, that is a high impact polystyrene. So, high impact polystyrene process, this is the process licenses ABS Lummus Global BP Chemical. The process produces wide range of general purpose and high impact polystyrene via bulk polymerization process. So, another grade of the polystyrene, that is the expandable polystyrene EPS, which called it the EPS expandable polystyrene. So, this is a process technology by BP Chemicals and ABB Lummus Global. Here in this process, we are making the expandable polystyrene. The process produces regular and the flame retardant grade EPS. It is batch suspension process followed by continuous dewating, drying and size classification. So, this was the about the various grade of the polystyrene. We discussed in this lecture about the polyolefins, polyethylenes and the polypropylene and the various process technology. And as I told you, the major driver for this development of the polymer industry, that has been the availability of the raw material, especially ethylene, propylene, benzene from the petrochemical complexes. And so for the in the near future, polyolefins, they are going to play a very important role, and with the coming of the metallocene catalyst, definitely the polypropylene, that will be used for more specialized purpose also. So, the next lecture will be lecture 3 will be discussing about the polyvinyl chloride and some other polymers also, which are finding wide application. Same thing has been in case of the polyvinyl chloride also, where the petrochemical companies, especially the naphtha cracker, they have played important role in the manufacture of the polyvinyl chloride and the cost reduction, because the earlier PVC, as I told you the while in beginning also, that was the acetylene route, from the acetylene to that was produced from the calcium carbide. So, in the next lecture we will be discussing about the PVC.